Hope that you are all familiar with the previous set of problems. Those were simple problems. Now let's see two more additional problems that will be regarding the Zener diode circuit. So far we have discussed about the voltage doubler circuits and voltage rectifier circuits. Now let's hope to solve two problems regarding the Zener circuit. So let's see this one, the sixth one. The circuit shown in figure is Zener diode in the on or off states. Very simple diagram, which is just looking into the diagram we can say that this is a voltage regulator circuit. So now by using the given values we have to check whether the diode is in the on state or off state. As you know, whether to check whether a diode is in Zener diode is in on state or off state, we have to calculate the voltage across this Zener diode, and if the voltage across the Zener diode is greater than the Zener breakdown voltage of the Zener, then it will be in the on state, and the voltage which appears across the Zener diode is less than the Zener breakdown voltage, it will be in the off state. So only one thing we have to do here is just calculate the voltage across the Zener diodes. That means if we denote these nodes, the dotted nodes here as A and B, we have to calculate what is VAB. This is our question. If VAB is greater than or equal to VZ, the Zener will be in the on state. If VAB is less than VZ, the Zener diode will be in the off state. So here some given quantities are here. The voltage is with a value. Voltage source as we am calling VI as 14, so it is 14 volt. Here the series resistance is denoted by R1, so we can also use that notation. R1 is equal to 1 K, means it is 1 kilo ohm. Then Zener diode is represented by D10V. D represents the diode, so Zener diode has a breakdown voltage of 10 volt, and the load resistance is given as RL is equal to RL is equal to, it is 3 kilo ohm. 3K is given, 3 kilo ohm. So this is the 3 kilo ohm value, this is the 1 kilo ohm. So these are the given values. So to find the VAB, just replace the Zener and find the voltage across AB. So the circuit can be redrawn like this again. This is a 14 volt cell. Here it is the R1, which is 1 kilo ohm. Then the load resistance RL is connected here, and we want to find the voltage across these two nodes A and B. So again we can write down the equation as VAB is equal to, can use the next sheet. So VAB is equal to, if you look here, VAB will be equal to the VRL, the voltage across the load resistance RL, which is equal to, if I is the current flowing through the circuit, then the same current will be flowing through the load resistance RL, so it will be I into RL. Now what is I? We have to find I, the current drawn from the battery by the circuit, that is I is equal to the total voltage divided by the total resistance. The total voltage is VI, is the given applied voltage, and the resistance is R1 plus RL. So which is equal to VI is 14 divided by R1 plus RL, that is 1 plus 3, which you can see that 14 by 4, which is equal to 3.25 volt. Sorry, 14 by 4 is 3.5 volt. So 3.5 volt is the, sorry, 3. This is kilo ohm, this is in volt, so it will be 4K, that is 14 by 4 into 10 raised to 3, which is equal to 3.5 into 10 raised to minus 3 ampere. So I will be equal to 3.5 milliampere. So this is the current flowing through the circuit. So VAB, the voltage across the Zener, VAB is equal to I into RL, so 3.5 milliampere is 10 raised to minus 3 into RL is given as 3 kilo ohm, so 3 into 10 raised to 3. So calculate this value, it will be 3.5 into 3, which you can get a value here. So now check whether VAB is greater than or equal to VZ, or VAB is less than VZ. So a comment to this answer is a first comment to this video, give this answer, what is the voltage across AB. The second comment say that by checking VAB is greater than or equal to VZ, or VAB less than VZ, comment which is on or off. So for this video, the sixth problem, you have to make two comments. First comment as the answer to this VAB, that is the numerical value of VAB is to be commented. The second comment is whether it is on or off. So the comment will be either on or off. So you have to make these two comments. The second comment is made according to the value of VAB. If VAB is greater than VZ, or VAB is less than VZ. If it is greater than or equal to VZ, the comment will be on, or if VAB is less than VZ, then comment will be off. So you have to make two comments for this video for this particular problem. So for sixth problem, you have to make the comment in this way. Now put a number 6, A part, you have to answer the value of VAB. For B part you have to say on or off. So now let's see the last problem. That is little more lengthy problem, but it is an easy problem. Let's read this question. Design a voltage regulator that will maintain as output voltage of 20 volt across a 1 kilo ohm load with AC input that will vary 30 volt and 50 volt. So you are asked to design a voltage regulator. Design means we have to calculate the different parameters in the circuit. Parameters means we have to calculate the resistance values or the sources of the voltage or the components. We have to select the values of the component which we are using in the circuit. So it is a voltage regulator circuit. You know that a simplest voltage regulator is a circuit which contains a Zener diode. So a voltage regulator circuit usually consisting of a DC source, a series resistance, a Zener diode and a load resistance. So we have to choose the values of the DC source which you have to use. We have to choose the values of series resistance, which we have to choose the Zener diode which is appropriate for our regulation or which gives a desired output value, and a load resistance. So but here we are given that the output voltage is desired, that is equal to 20 volt. So let's write the values here. V out is 20 volt across a 1 kilo ohm slot. So load resistance is also fixed and is given as RL is equal to 1 kilo ohm. Then the input voltage will vary 30 volt and 50 volt. So input voltage can vary from 30 volt and 50 volt means VI, the input voltage minimum is 30 volt and VI maximum is 50 volt. So we have to design a circuit in such a way that it gives an output voltage of 20 volt when we are having a 1 kilo ohm load resistance connected, and the input voltage varies between 30 volt and 50 volt. So now we have to choose the Zener value. Vz is equal to what, and what should be the series resistance that must connect in series with the voltage source. And also while choosing the Zener, we have to choose not only the Zener voltage but also the maximum current that the Zener can carry. So these two values Vz and Izm are the parameters which should be kept in mind while choosing a Zener, and also we have to calculate the R value which should be connected in the circuit. So let's draw a circuit here. Voltage regulator will have a voltage source here. A series resistance is connected with a Zener in the reverse biased condition, and a load resistance RL is connected here. So this is the circuit diagram, and given that this RL is equal to 1 kilo ohm, This voltage is a variable source with a voltage specification varies from 50 to 30 volt. So these are the given things, and desired output voltage is also given. The output voltage should be V0, which is equal to 20 volt. So we know that to get an output voltage V0 voltage stabilizer, the output voltage is V0 is equal to the Zener voltage. So Vz should be equal to the output voltage. So we can say that Vz should be 20 volt. Now we have to calculate this Izm. Before that, just represent the currents here. The current flowing through the circuit, let it be I, which is the current supplied by the battery to the circuit, and IL is the current flowing through the load, and IZ is the current flowing through the Zener diode. Now we can write the current equation as I is equal to IL plus IZ So when the Zener is in the on state, we can write this load current does not vary because we are using a constant or fixed, it's better to use fixed RL. IL should be constant. That is the important thing here. If IL should be constant, then when the diode is just switched on, that means if you consider the reverse characteristics here, when V equal to voltage across the Zener is Vz, we can take Iz is equal to 0. That means minimum current drawn from the battery, that is when I minimum is equal to IL plus IZ minimum. So this is the minimum Iz value is 0. So I minimum is IL I minimum is IL, but we know that V0 is equal to IL into RL, and it is given here V0 and RL. So IL is equal to V0 by RL. V0 is 20 volt divided by 1. K is the load resistance, so it is 20 by 1 is 20, and kilo ohm, that makes it as milliampere, so 20 milliampere. So I minimum value of the current drawn from the battery is 20 milliampere. The minimum value of the current will be drawn when the voltage is V minimum. So across the resistance R, we can say that the voltage is V in minimum or V in minus V0 or Vz is equal to I into R. So when V is minimum, then I also minimum into R. So R value is given by V in minimum minus V0 divided by I minimum, which is equal to V in minimum is given as 30 volt minus V0 is 20 divided by I minimum is 20 milliampere. So which is equal to 10 by 20. 10 by 20 is 0.5 milliampere is divided by volt by milliampere, so it is 0.5 into 1000, so it is 500 ohms. So R will be 500 ohm. Now using the current equation, I is equal to IL plus IZ. When I is maximum, since load resistance is fixed, load current is also constant or fixed. So IL plus IZ maximum or IZM. The maximum current is drawn from the battery when V in is maximum. So we can write V in maximum minus V0 will be I maximum, the maximum potential drop across R will occur, I max into R. So I max is equal to V in maximum minus V0 divided by I max, which is equal to V in maximum is given as 50 volt minus V0 is 20 divided by I max, sorry, not I max, here it is R. I max is equal to Vi max minus V0 by R. So R is given as or obtained as, not given, it is, we are already calculated it as 500 ohms. So it will be I max is equal to 30 by 500, it is equal to 0.03 by 50, which is 0.06, so it is 60 milliampere. So 60 milliampere. Now IZM, the maximum current that the Zener can carry is given by IL max minus IL. So IL max is obtained here, so not IL max but it is I max, sorry, I max minus IL. So I max is obtained as 60, IL is obtained as 20. So by substituting those values you will get a value for this IZM. So comment the answer for IZM as the another comment to this video. So you have to make 3 comments to this video. So we have decided or designed the values of R as 500 ohm. Then the voltage Zener used must have a breakdown voltage of 20 volt and IZM will be obtained by U. So all these values once known, then we can have a voltage regulator circuit like this. So that's all about the problems. So again I am specifying you that for the first video you have to make a comment for that answer, a single comment. For the second video you have to make a comment for the answer to the second part of the third problem, and also the comment to the fourth problem. So you have to make 2 comments against the second video, and for the third the third video you have to make 3 comments, 1 comment for the sixth, 2 comments for the sixth problem, and 1 comment for the seventh problem, the value of IZM. So you have to make 3 comments against this video. Remember that all the comments should be made in the Google Classroom. Okay, thank you.